Welcome to solverfy.
Hello there. So for this exercise we need to count how many 4 elements RNA sequence that contain U. So let's remember that the amino acid bases that compose the RNA are A, C, G, and U. So A is for adenine, C is for cytosine, G guanine, and U for uracil. So technically we need to see how many of those 4 sequence RNA have contain at least one U, right? So that's the idea of contain a uracil. So so the way to calculate this is first count all the possible combinations. So all the combinations or all the possible sequences or all the sequences, okay? So all the possible sequences going to be, we have a four element sequence, so for each position we can put 4 possible letters A, C, G, or U. So we have here 4 possibilities, and we can repeat, of course, these letters. So 4, 4, and 4. Using the multiplication rule, we have that all the sequences is equals to 4 to the 4. But now, how to count those that has at least one U? Well, we can take all the sequences, okay, all the sequences, and then subtract all the sequences, all those sequences that has no uracil, okay, and the subtraction is going to give us all those sequences that has at least one uracil or that contain uracil in it. So the number of those that the sequences that doesn't have a uracil on the sequence are, we have 4 strings, but now instead of 4 possibilities we have only 3, because we are eliminating the possibility to put the uracil on the sequence. So we have 3 times 3 times 3 times 3, and is equals to 3 to the 4 power. So at the end, what we want to calculate, that is the number or all the possible sequence that contain a uracil on it. It's going to be 4 to the 4 power minus 3 to the 4 power. Then work, and this is equals to 175. Great. Now we need to count all those sequences that do not contain, so do not contain the following subsequence or sequence, that is CUG. Okay, so that means that we need to avoid to have in our string these 3 consecutive letters. But again, we're going to use the same procedures as before. We're going to count first all the possible sequences, and we're going to subtract all the sequences that contain these three consecutive letters. So all the sequences we have already calculated is equals to, this is equals to 4 to the 4 power, and we just need to calculate this value here. So let's suppose that we have here our 4 string, and we need the 3 consecutive letters. So they can be either on this position CUG, and we have here one free place that could be any other letter, and the other possibility is that these 3 consecutive letters are located in this position CUG, and in this case the first place is going to be free of choice. So this results into 4 possibilities here plus 4 possibilities here. We have 8. So at the end, the number that we want to compute is the number of strings that do not contain this sequence CUG, this consecutive sequence. Okay, so that is equals to 4 to the 4 power minus the 8, and this is equal to 248. Great. Now we need to count all those sequences that do not contain the sequence AUCG. Okay, so how many of these strings do not contain those? Well, you can see that if yeah, do not contain all four, okay, all four bases A, U, C, and G. Okay, so that means that it doesn't contain the four possible. So you can construct a sequence of A, U, C. So you can see that here we don't have the letter G, so it's not considered the four bases. So in this case, we need to, again, we're going to use the same procedure as the previous ones. We're going to count first all the possible sequence, and we're going to subtract all the sequences that have the four bases. Okay, so the sequences with the four bases. So we just need to calculate this number. So the sequences that contain the four bases are the ones that do not repeat the letters. So here we have four possibilities, but if we're not going to repeat the same letter, we need to here, now we have here three possibilities, then we have two, and then we have here one. So at the end, the number is going to be 4 factorial. So that means that the one that we want to, the quantity that we want to calculate is the number of strings that do not contain the all four bases. So not contain the all four bases. So all the possible sequences is, as we calculated at the beginning, 4 to the 4 power, and the sequences that contain the four bases elements, the four bases amino acids, is equals to 4 factorial, and this is going to be equal to 232. And the last thing that we need to count is all those that contains, all the strings or all the elements of RNA that contains 2 of the 4 bases. Okay, so the bases are A, U, C, G, and U, right? A, U, C, and G, yes. Adenine, uracil, cytosine, and guanine. So how many combinations of these two letters can we form? Okay, so we can form AU, AC, AG, then we have UC, UG, and finally CG. So these are all the possible pairs of these four bases that we can form. And for each of these ones, we need to create a sequence that contains these two elements here. So that means that we have here 4 elements, and for each position we have 2 possibilities that are these 2 possible letters. 2, 2, 2. This equals to 2 to the 4 power. But we need to be careful, because one of these, all the possible combinations are going to be a string that contains only the first letter or only the second letter, right? So we need to take this value and subtract 2 to avoid to count those sequences that have just one letter. So for each of these possible combinations of groups of 2 letters, we have this 2 to the 4 minus 2, 2 to the 4 minus 2, 2 to the 4 minus 2, and so on. So the result for this part, we have here 6 possible combinations of pairs of letters. So we have 6 times 2 to the 4 power minus 2, and this is equals to 84.